Hello and welcome to the channel. This is Fridays with Brandon, and we have a guest speaker again for part 3 of scope meters and MDA 550. How do you use them and get the most out of them? So we're going to over more pro tips. We did have 2 previous videos. You can go back and watch those if you haven't already. But we're going to talk about how do you take the information and how we did the logging before and how we pull that information off and what it's going to look like in the software. So we're going to show you how to do that within FlukeView, FlukeView Forms, I think. Jim can correct me
Two,
on that in a second.
FlukeView 2, like the second
FlukeView 2.
rendition. Yep.
Okay, so FlukeView 2, we're going to go over FlukeView 2 and what that's going to look like. And then we will show you how you would save this information if you wanted to as a CSV. And then you can open it up in Excel if you don't have FlukeView 2. But you're going to find that FlukeView 2 is a much more seamless process and has actually been thought through. And you'll probably be happier with that experience. So, Jim, thanks. Hopefully these
Yeah.
people have already watched our first 2. So we're going to jump into this, and you're going to share your screen. I'm going to throw this up for us, and you're going to walk us through. This is what FlukeView 2 looks like. And why don't you tell us how we download these and what this looks like?
Sure. So what I did just to save a little bit of time is I created 3 different parameters. I did what's called there's 2 recording functions. There's trem plot and scope record. And then the third item is what I call pass fail, where that you get to have a known waveform that's good. You put an envelope around that waveform, and then anytime the waveform goes outside of that envelope, it saves it, and you can get up to 100 of those um, using what's called the replay mode. But anyway, just to start off, I'll just go over here on the right. This is a trem plot function. So when you go into the recorder mode, you have either trem plot or scope record. Trem plot is a slower sampling rate feature, kind of like an old chart recorder. The sample rate for the meter is 250 milliseconds, and it just plots whatever reading you want. You can do voltage, AC or DC voltage, or frequency, or if you have a current clamp, you can measure amperage. Anyway, so I'm going to go ahead and open that up to look at the details of it. So I
So, Jim,
simply, yeah, go
let
ahead.
me cut you off a second. Before we start opening the files, can you show them how you got the files on to
Good point.
FlukeView?
Thank you. So over here in the software program, you have a number of different choices. So open is one of them. So you can say open from the instrument. The reason it says from file is that you've already previously stored it on your computer. But in this case, we're going to be talking to the meter directly. So I'm using a USB cable. So if you click on from instrument, you can say that it's an active thing where you haven't saved it into the memory yet, or it's a replay function, or it's been saved into the internal memory. So if you click on saved, then it opens up and shows you the files that you have saved in the memory. I have 4 files here. But yeah, you just go ahead and click either replay or the recorder or the trem plot. And I've already done this. So, but that's a good point, Brandon. How do you do it?
Excellent.
So this is the trem plot, this is the scope record, and this is the pass fail envelope function. So if you open this up, you can say, oh, I'm going to do it's calling it a waveform, but really it's a trem plot. So you click on this, and now you can view this information. You can turn on cursors if you want to, and these will go along the plot line. Over to the right here, you have your cursor value. X1 is cursor number 1 in time, from 0 over here to, well, it was about 5 seconds or something of that nature. And then X1 is the amplitude. It's 121 volts, 0.7 at this point. If I move it over here, then it drops down to 76.8 volts. And then there's a delta between the 2 cursors. So as far as the voltage differentiation between cursor 1 and 2 is 45 volts. This is at 121 and this is at 76. And then the delta time. So this is at 7 seconds into the recording. This is at 39 seconds. And then there's 32 seconds between the 2 cursors. You can also copy the raw data if you wanted to. So I could click on this and it'll copy it to the clipboard, and then I can paste it into Excel, or you can copy the screen where it's just a picture, like a graphical representation. It'll just look like this, and you can paste that into Excel or Word or anything, quite frankly. You can also use a zoom function, which you can see you can zoom in like this, or you can go like this by holding your left mouse button down and drawing an envelope around the information. So
Very good.
anyway, and then the same thing holds true for this. This is the scope record function. Now, the thing that I get a lot of calls on from tech support is that somebody is going to want to review a waveform for a long period of time, and the scope record uh, mode is limited to 100 screens of time, each screen equivalent to 12 divisions of whatever the time base you're using. Well, the smallest time base you can use in the scope record is 4 milliseconds per division. So it doesn't equal out a whole lot of time. I think that works out to about 4.8 seconds. Right now, we're only looking at, this much, but I can pull this. And this is me turning the power on and off on a wall, on a power strip. So you can see that total amount of time if I turn the cursors on. Is the delta is 4.779 seconds. It's not a whole lot of time. But I can zoom in on this if I wanted to, see the transition, and have the cursors. Oops, copy that on accident. So, I mean, it's interesting, it's good, but you're just limited to so little of time. You can get into that point. But what I'd like to transition over to is the thing that I usually tell people what to do, is to use the pass fail function. So in this situation, I had 0 AC voltage, and it's taking these 100 screenshots, and you can see the transition period for multiple events. And this could have taken, a minute, could have taken a day, could take a week. It's not based off of time. It's based off of how many events occurred outside of the waveform envelope that you created. And the same thing goes, you can copy the data, you copy a picture, you can turn the cursors on, same principle.
Yeah. And you can see, I mean, I'm looking right now. So you can see it will be time and date stamped. So if you left it on for a day, you can get in here, see on the x-axis what the time and date stamp is during
Yeah,
that event.
it's over here.
Yep.
So anyway, we wanted to keep this as short as possible to keep you from being bored. But that's in a nutshell, 3 functions: scope record, trend plot, and the pass fail envelope capturing capability.
Yep.
And
sorry, Jim.
yeah, and then Brendan and I thought we'd transition over to showing you how to save the data as a CSV file onto a thumb drive is the other feature. Let's say
Yep.
you don't have Fluke View and you don't want to pay for it, you just want the raw data, then that is also another function.
Yeah, so this is kind of what we're talking about. So this is the trend plot, similar to what Jim showed earlier. And we're going to kind of go through how do you do this. So when you decide to save, you hit F1 and it's going to look like this, right? And then we have either internal memory or USB. If you don't have Fluke View, then you could do USB and save it as a CSV file. Okay. Oh, yeah. You have to go back here and do file options, I guess, right?
Right.
And then data to CSV to USB. Okay. And
Yeah, you can give it a name, so on and so forth. There's some other features there.
oh, yeah. Give it a name there. And then this is going to be, you've already done either that envelope from the pass fail test from the part 2 of this video series, or you've done scope record or trend plot and you've saved it already, and now you're trying to transfer it to a USB stick because it was already saved internally. Is that correct, Jim?
You have a choice when you're saving it. You can save it directly to, because right now in this screenshot that Brandon is sharing, it's saying that we're going to save it to the thumb drive. That's why it says USB. The INT lettering there means you're going to save it to the internal memory of the scope meter.
Okay.
So in this
So
example, I have a thumb drive plugged into the scope and I'm saving the raw data, the CSV, onto the thumb drive. And so here's not being in the trend plot anymore. We're back into showing a live waveform.
yeah, and we're doing some kind of recording, it looks like. And then we stopped the recording.
Yeah, so that was in the scope record mode. And
Okay.
we're telling it again, we want to save it to the thumb drive. That's why it says USB. And then when I say I want to save it, I can save it as a CSV file. It's one of the
And
choices.
you can't get the scope meter to do this as a default. It's always going to default to internal. So every time you do this, you're going to have to tell it, I want to use a flash drive or a USB thumb drive.
Good point. Yeah, that's a little frustrating, but once you know it, then you can work with it. But yeah, every time you go out of the mode and come back in, it won't remember that you wanted the thumb drive as a reference. It wants to go back to internal memory.
Yep.
Good point, Brandon. And so this is the pass fail envelope mode.
Yep. And we're going to show some examples. Oh, that was the last example, I guess. So it just shows you same thing. You can save it as a CSV. And what does that get you with the CSV? That gets you the ability to bypass Fluke View and go straight to Excel. And then depending on how good your skills are at Excel, you could plot these out and do all sorts of fun things with it. But we think that the most seamless process is to buy the kit version that already comes with the software, or pay for Fluke View, and then go ahead and use Fluke View because it presents it much more seamless than you having to be an Excel expert. So
Right. Good point, Brandon. That's really good. Yeah. So I end up spending quite a bit of time kind of teaching people how to use Excel when they do the CSV and do that. So, but for those engineers that are familiar with that, then it's not a problem for there, because you get the time and date stamp and the amplitude of the waveform along the points. So,
okay.
yeah.
Well, I just want to take this moment to thank you, Jim, for helping with this 3-part series. Already got a comment on the first part that
Oh, really?
Jim's a legend. So, and I guess I don't know if that means you're famous or infamous, but you're remembered.
Right.
So,
That's good. Thank you.
thank you for this time, and we'll see you guys in the next video.
All right. Take care, everybody.
Take care.